Hello everyone, good evening. I think my voice is audible. Yes. So welcome. This is lecture number 4 of linear algebra. So if you haven't watched the previous class, so go through previous class because this is a continuation of previous class. So in the previous class we have started system of equations, right? We have started system of equations. So in this class I'll wind off the system of equations. So in 1 hour I'll complete the topic. So why I'm doing this, because you need this idea to extend the idea of linearly independent, linearly dependent basis and dimension, right? Okay. So I'll just give a clarity of what we have did so far, right? What we have did so far, I will just give you the clarity. Just a minute. So you can see the syllabus in the very first class I've given you syllabus, right? So we are completed vector spaces over R and C. That is the first class we are done, right? And then we have to move on to this topic, that is where is the topic? Yes, rank of a matrix and then solution of system of linear equations, right? So directly I have moved to the topic. Don't worry, our next topic will be linear dependence and linear independence, right? To solve, to give more idea about that, I have introduced this topic and then we'll be moving on to that topic, right? So as of now we have completed vector space over R and C. Just a minute. Okay, I think we have completed vector space over R and C, and then rank of a matrix and solution of system of linear equations, right? So in this class we'll be completing system of equations. Yes, so if you haven't watched the previous class, so please watch previous class because this is the continuation of previous class. In the previous class, we have introduced what is meant by non-homogeneous system of linear equations. And then we have solved 7 problems based on that, right? The previous class, we have introduced non-homogeneous system of linear equations. Based on that, we have solved 7 problems in the previous class, right? And then I have given you very short note that consists of only one slide where you can do any problem if you know, if you understand this single slide. Yes, this is a single slide, right? Case 1, case 2, case 3, case 4. Uh, if rank of A and rank of A comma B both are equal to 3, the system is consistent and has unique solution. That is, both has to be equal total number of variables. If both are equal to 2 and less than total number of variables, we will have infinitely many solution. In the previous class, we have discussed all this. If both the ranks are equal to 2 or if both the ranks are equal to 1, that is augmented matrix and A matrix, then the system is consistent and has infinitely many solution. If rank of A and rank of A comma B they are not equal, then it has no solution. So based on that, in the previous class, we have solved almost, yes, we have solved 7 problems, right? So we'll continue with the 8th problem. So another 5 more problems I'm going to do based on finding the unknowns. That is, for what value of this unknown, this system will have unique solution like that, right? So straight away we'll get on to the problem. So, so if you haven't, again I'm repeating, if you haven't watched the previous class, go through that class and then come back to this video. Okay, so investigate the value of lambda and mu. The system of linear equations. See, first it is non-homogeneous. Why? Because you can see the output vector 9, 8, mu, which is non-zero vector, right? Because 9 is non-zero. So therefore, the output vector is non-zero. So therefore, the system is non-homogeneous system. So consider Ax equal to B. So what is A? A is the coefficient matrix, so which is 2, 3, 5, and here 7, 3, minus 5, 2, 3, lambda, and x is the unknown, so which is x, y, z is equal to B. B is output 9, 8, mu, right? See, first we need, there are 3 questions here. What value of lambda mu should be inserted to get unique solution? What value of lambda mu should be inserted here to get infinitely many solution and to get no solution? So first what we'll do is we will form an augmented matrix. So first we will form an augmented matrix. So which is 2, 3, 5, 9, 7, 3, minus 5, 8, 2, 3, lambda and mu. So what we'll do is we will reduce this to row echelon form. This is our first step, right? So first we'll reduce this to row echelon form. So we have R2 is transformed to 2 times R2 minus 7 times R1, right? Because 2 sevens are 14, 2 sevens are 14, 14 minus 14 will be 0. So R3 is transformed to R3 minus R2. See, for reducing to row echelon form, first row, first non-zero element, below the corresponding column, every element has to be 0. So therefore, this matrix is equivalent to 2, 3, 5, 9. Now, what you have to do? Just multiply 7, multiply 2 and then subtract will be 0. Now, multiply 7, multiply 2 here, this will be 6 and multiply 7 here, it will be 21. So, it will be 6 minus 21. 6 minus 21 is minus 15. Here you multiply 2, this will be minus 10. Minus 10, you multiply 7 will be 35. So minus 10 minus 35 is minus 45. Now you multiply 2 here, it will be 16. You multiply 7 here, this will be 93, 63. So 16 minus 63. 16 minus 63. 16 minus 63. So there will be minus 47. Right? And here you have to subtract 2 minus 2 is 0, 3 minus 3 is 0, and this will be lambda minus 5, and this will be mu minus 9. Now already it is in row echelon form, right? In the first stroke itself, we made this into row echelon form. Why? First row, first non-zero element, below that everything is 0. Second row, see our aim is making this as 0. In that process, this turns out to be 0, right? So second row, first non-zero element, below that everything is 0. Third row, there is no non-zero element. So every element below that is also, there is no below element. So therefore, this is row echelon form. Now, we'll move on to finding all values. So first is unique solution. See, for unique solution, rank of A, the rank of A comma B, both are equal to 3. This is a condition, right? Rank of A and the rank of A comma B, both are equal to 3. Now, very important thing, if this number is non-zero, regardless of this number, see, this can be 0 or this cannot be 0. I don't care about that. If this number is non-zero, then surely rank of A and rank of A comma B both will be equal to 3. Yes or no? See, this can be 0 or this cannot be 0. I don't care about this element. If this number is non-zero alone, non-zero, it should not be 0. If this number is non-zero, what will be the rank of A? It will be 3 because this number is non-zero. So this is non-zero row. And when you look at overall, regardless of this number, since this number is non-zero, this entire row is non-zero, non-zero, non-zero. So the only thing is, for to be a unique solution, rank of A and rank of A comma B both has to be equal to 3. Lambda minus 5 should not be equal to 0. If this happens alone, then this will always have unique solution. That is, lambda should not be equal to 5. Lambda should not be equal to 5. Mu can take any real number, right? Mu can take any real value. Because whatever you put mu, this, I don't care about this element at all. If this element is non-zero, then that will always have unique solution. So lambda should not be equal to 5. So lambda can take any real number except 5, and mu can take any real number. So when you insert this value, then this will always have unique solution. Is this clear? Lambda can take any real number. You can give any real number, but you should not give 5. Apart from 5, you give any value of lambda. You give any value of mu, then that system will always have unique solution because rank of A and rank of A comma B both are equal to 3. Yes. Now for second, now for infinitely many solution, what is the condition? Rank of A and rank of A comma B both should be equal to 2. Yes or no? Both should be equal to 2. That means, this number also should be 0. This number should be 0. Yes or no? If this is 0, then your rank of A will be 2 and the rank of A comma B will be 2. So for this condition, lambda minus 5 should be equal to 0 and mu minus 9 should be equal to 0. That means lambda has to be equal to 5, mu is equal to, then there is only one value of lambda and mu. There is only one value of lambda and mu. That lambda is 5, mu is 9. That makes this as infinitely many solution. Now next is for no solution. For no solution. For no solution, rank of A and rank of A comma B should not be equal. Rank of A and rank of A comma B should not be equal. So what I'm going to do is, I'm going to make this element 0 and I'm going to make this element non-zero. Right? So this is a condition for every problem. Remember this. For a no solution, I'm going to make this as 0 and I'm going to make this as non-zero. If this happens, then rank of A will be 2 because this element is 0. So this will be 0 row. So you have only 2 non-zero row. And when you look at overall, if this number is non-zero, then this is a non-zero row. This is a non-zero row. In that case, rank of A comma B will be 3 and rank of A will be 2. When is that? Lambda minus 5 should be equal to 0 and mu minus 9 should not be equal to 0. If this is 0, rank of A will be 2. If this is non-zero, rank of A comma B will be 3. In that case, it will be no solution. So that means there is only one value for lambda you should give, that has to be 5. Mu should not be equal to 9. That means mu can take any real number except 9. This is the condition that this will have no solution. Is it clear? Very, very important problem. Very important problem. This is the simple idea based on finding the unknowns so that it has this solution, it has infinitely many solutions. Okay, we'll move on to we'll do one more similar problem. Investigate for what value of lambda and mu the system has no solution, unique solution, infinitely many solution. So first ax equal to b, right? Ax equal to b. What is a? A is 1 2 1 and here it is 1 1 lambda and here it is 1 3 minus 5 and here x is x y z which are unknown variable and your b is output vector 7 mu 5. So form the augmented matrix A comma B. So A comma B is 1 2 1 7 1 1 lambda mu 1 3 minus 5 5. See, whenever you have this kind of problem, it is always better to keep the unknown in the last row. It is always better to keep the unknown in the last row. So what I'll do is I'll just shift R2 and R3. I'll just interchange R2 and R3. So this will be 1 2 1 7 1 3 minus 5 plus 5 and 1 1 lambda mu, right? It is always better to have this in the last row. Now reduce to row echelon form. So R2 is transformed to R2 minus R1, R3 is transformed to R3 minus R1. So this is equivalent to 1 2 1 7. So 1 minus 1 is 0, 3 minus 2 is 1, minus 5 minus 1 is minus 6, 5 minus 7 is minus 2, R3 minus R1, 1 minus 1 is 0, 1 minus 2 is minus 1, this is lambda minus 1, this is mu minus 7. Right now it is not in row echelon form, so we will make use of R3 is transformed to R3 plus R2, right? Because second row first non-zero element, below that everything is 0, but we have minus 1 here. So after this this transformation, your reduced matrix is 1 2 1 7 0 1 minus 6 minus 2. I'm just adding R3 plus R2 because it is minus 1 plus 1 here. So 0 0. This is lambda minus 1 minus 6. So this is lambda minus 7 and this is mu minus 9. Right now this is in row echelon form. So again we will follow the same thing. Right, again we will follow the same thing. For unique solution, this has to be not equal to 0. This one is enough. If this number is non-zero, means surely it will have unique solution because rank of A and rank of A comma B both will be equal to 3. So that means lambda is not equal to 7. So lambda can take any real number except 7. Mu can take any real value because regardless of this number, this number is non-zero alone is enough to get rank of A and rank of A comma B both equal to 3. Now for infinitely many solution, rank of A and rank of A comma B both has to be equal to 2. That means this has to be 0, this has to be 0. So lambda minus 7 has to be 0 and mu minus 9 has to be 0. So you put lambda to be equal to 7, mu to be equal to 9, then this will be 0, this will be 0. So rank of A and rank of A comma B both are equal to 2. So in that case you will have infinitely many solution. And for no solution, um, lambda minus 7, I'm making this to be 0 and mu minus 9 is not equal to 0. So that means you put lambda is equal to 7 and you should not put mu is equal to 9. That means you can put any real number except 9. So for this, we will have no solution. Is it clear? We'll move on to third problem. See, these kinds of problems are very important. You can always expect these kinds of problem in system of equations. So for what value of unknown, this will have unique, this will have infinite, this will have no solution. These kinds of problems are very important. Okay. Yes. So I'll give you one exercise problem for you. So take the exercise. So you comment in the comment section. Investigate for what value of lambda and mu the system of equation have no solution, unique solution, and infinite number of solution. So you take this as an exercise problem. So in the comment section, you comment your answer. For what value of lambda, it will have no solution, unique solution, and infinite number of solutions. Right? Okay. So we'll move on to 11th problem. Find the value of k. Find the value of k for which the equations kx minus 2y plus z is equal to 1, x minus 2ky plus z is equal to minus 2, 1 minus 2kz have. Okay, so the previous problem we have two unknowns, lambda and mu. Here there is only one unknown which is k. So we'll do this problem. So first what I'll do is I'll form an augmented matrix A comma B. So augmented matrix will be k minus 2 1 1 1 minus 2k 1 minus 2 1 minus 2 k 1, right? So I always said that you always it is better to have 1 here, right? In one of the problem I said it is better to have 1 in the first row first element. So what I will do is I will shift r1 and r3, or you can also shift r1 and r2 also. So if I shift this 1 minus 2 k1 1 minus 2k 1 minus 2 k minus 2 1 1. So reduce this to row echelon form. So r2 is transformed to r2 minus r1, r3 is transformed to r3 minus k times r1, right? Because 1 is here, so multiply k with that. So k minus k will be 0. So this is equivalent to 1 minus 2 k1. So 1 minus 1 is 0, minus 2k plus 2, minus 2k plus 2, and this is 1 minus k minus 2 minus 1. So this is minus 3. So this is k. You have to multiply k here and then you have to subtract. You have to multiply k here. So minus 2 plus 2k. Minus 2 plus 2k. And here you have to multiply 2. You have to multiply k here and then you have to subtract. So this will be 1 minus k square. You have to multiply k and then you have to subtract. So this is 1 minus k. Now you can see this element can be made easily 0 because both are opposite signs. So R3 is transformed to R3 plus R2. So therefore this is equivalent to, so 1 minus 2 K1, 0 minus 2K plus 2, 1 minus K minus 3. Now I'm just going to add R3 plus R2. So minus 2 plus 2 will be 0. 2K minus 2K is 0. And this will be 1 minus K square. 1 minus K square plus 1 minus K. And here if I add 1 minus K minus 3. Right? 1 minus K minus 3. So simplify this. So when you simplify this term, you will have minus K square minus K plus 2. So if I take minus outside, you will have K square plus K minus 2. So factorize this. Factorize this. Factorize this. So if I factorize K square plus K minus 2, so your sum is 1 and your product is minus 2. So this will be 2 minus 1. So K square plus 2K minus K minus 2. Just take K outside. K plus 2 minus 1 will take K plus 2. So this factorization is K minus 1, K plus 2. And this will become minus K minus 2, right? Minus K minus 2. Okay. So this will become, this is equivalent to, so 1 minus 2 K1, 0 minus 2K plus 2, 1 minus K minus 3, 0, 0. This is minus of K minus 1, K plus 2, and this is minus K minus 2. So this matrix is in row echelon form, right? This matrix is in row echelon form. Now we will proceed with problem. Now uh, for unique solution, this, see, this element should not be equal to 0, right? This element should not be equal to 0. This element will be equal to 0 if k is 1 or if k is minus 2, right? Both has to be 0, right? Both has to be sorry, for unique solution this has to be non-zero. If this has to be non-zero, if this has to be non-zero, you should not put k to be equal to 1 and you should not put k to be equal to minus 2. Yes or no? You should not put k to be equal to 1 and you should not put k to be equal to minus 2. Yes or no? For that to be non-zero, you should not put uh, k to be equal to that and k to be equal to this. Just a minute. Yes. So for unique solution, you should not get k to be equal to, yes. Hurry. So for unique solution, this term should not be equal to 0. That is minus of k plus 1, k minus 1, k plus 2. This term should not be 0. That means k should not be 1 and k should not be minus 2. So that means k can take any real value except 1 and minus 2. If you put any value of k here, then the system will always have unique solution. Now, for infinitely many solutions, both the term has to be 0, right? Minus of k minus 1, minus of k minus 1, k plus 2 has to be 0, and both has to be 0, and minus k minus 2 has to be 0. So both has to be 0. So this will be 0 when k is 1 and minus 2. This will be 0 when k is minus 2. So both, that means minus 2 is common. So that means if k is minus 2, then this will have infinitely many solutions. See here, this will be 0 when k is 1. But if you put 1 here, this will not be 0. Yes or no? This will not be 0 if you put 1 here. So both will be 0. So you find a k such that both has to be 0. That means k has to be minus 2. So when k is minus 2, it will have infinitely many solution. Now for no solution, this number minus of k minus 1, k plus 2 has to be 0, and that this number should not be 0. Yes or no? If this is 0, rank of A will be 2. If that is not 0, rank of A comma B will be 3. Rank of A comma B will be 3. So in that case, this will be 0 when k is 1 or minus 2. But your k should not be equal to minus 2. That means that means k has to be equal to 1, right? Because k is equal to 1 is common for both. When k is 1, this will be 0, this will be non-zero. That means your rank of A will be 2 and that will be non-zero. So rank of A comma B will be 3. So therefore, this is the so for unique solution, k can take any real number except 1 and minus 2. For infinitely many solution, k should not be equal to minus 2, and for no solution, the value of k should be equal to 1. I'll check the answer. Yes, correct. Yes. So I think you can take this problem as exercise. For what value of eta the system of equation have a solution, and solve them completely in each case. You have to find the solution also, right? You have to find the solution also. Okay, I'll give you some hint. So first I'll form the augmented matrix. So we have 1 1 1 1 1 2 4 eta 1 4 10 eta square. So we'll reduce this to row echelon form. So R2 is transformed to R2 minus R1. R3 is transformed to R3 minus R1. This is equivalent to 1, 1, 1, 1. So 1 minus 1 is 0, 2 minus 1 is 1, 4 minus 1 is 3, and this is eta minus 1. 1 minus 1 is 0, 4 minus 1 is 3, 10 minus 1 is 9, and this is eta square minus 1. So we'll make an operation. R3 is transformed to R3 minus 3 times R2. R3 minus 3 times R2. So this is equivalent to 1, 1, 1, 1, 0, 1, 3, eta minus 1. So you multiply 3 here, you multiply 3 here and subtract. You multiply 3 here and subtract, and this will be eta square minus 1. You multiply 3 here and then subtract. For what value of eta the equation have a solution? Surely if this has to be 0, then only you'll have solution, and solution will be infinitely many solution. Unique solution is not at all possible. Unique solution is not at all possible. For unique solution, this has to be non-zero. Then only we can try for unique solution. So this is equivalent to 1 1 1 1 1 1 1 1 0 1 3 eta minus 1 0 0 0, and this will be what? And this is eta square minus 1 minus 3 eta plus 3, eta square minus 3 eta plus 2, eta square minus 3 eta plus 2. So we'll factorize this. What is the factorization of eta square minus 3 eta minus 2? Your sum is minus 3 and your product is 2. So it is minus 2 minus 1. So eta square minus 2 eta minus eta plus 2. So when I take eta common, it will be eta minus 2. So eta minus 1, eta minus 2. Right? So this will have a solution. This will have a solution. The solution is infinite. And the solution is infinite if eta minus 1, eta minus 2 is 0. That means eta is equal to 1 or eta is equal to 2. So in both the case, you will have infinitely many solution only, right? So and solve them separately. That means what? If eta is equal to 1, you find the solution. See, if eta is equal to 1, to solve them separately, if eta is equal to 1, the reduced echelon form is 1 1 1 0 1 3 0 0 0, and this is, yeah, usually when we are solving, we will write the reduced echelon matrix to Ax equal to B form. That is what I am doing here. This is a reduced echelon matrix. If eta is 1, this will be 1 0 0, right? Now solve this. Number of free variable is one free variable. I'm not going to do this, right? So number of free variable is 1. So assume z is equal to k and solve for xy. So you can see here you have x plus 3y is 0. So y is x is equal to minus 3y. In that case, what you can do is, y plus 3z is 0. So y is minus 3z. So y is minus 3k. That way you can find x. And similarly, you solve for, if eta is equal to 1, you find the infinitely many solution. If eta is equal to 2 again, you solve and find that infinitely many solution. I think you can do this, right? Very simple. So if eta is equal to 1, you will have a new system of equations here. Find the solution. If eta is equal to 2 again, just 2 minutes work, right? You can do this problem. Yes. So I think you'll have clarity on solving a non-homogeneous system of equations, right? So when you are comfortable in solving non-homogeneous system, easily you can solve homogeneous system of linear equations. So the homogeneous system is the same thing, but the output vector will be 0. The output vector will be 0. So that means Ax is always 0. Ax is always 0. Usually we will have Ax equal to B. B is non-zero, means it is non-homogeneous. If your output vector is 0, then it is homogeneous system of equations. To find solutions, that is your equation will be a11x plus a12y plus a13z is 0, a21x plus a22y plus a23z is 0, a31x plus a32y plus a33z is 0. So you can see your all output vectors are 0 vector. So this is a homogeneous system of equations. Here you will have only two types of solutions. The first type is unique solution, which is also called trivial solution. That is, x is equal to 0, y is equal to 0, z is equal to 0. See, for this 0 comma 0 comma 0 is always solution, yes or no? When you put x is equal to 0, y is equal to 0, z is equal to 0, this is always a solution, yes or no? 0 0 0, because everything will be equal to 0. So that solution is called trivial solution. So whenever you have a unique solution, that solution has to be 0 solution whenever your system is homogeneous system. But for non-homogeneous, we don't know. Right? But whenever your system is homogeneous system, and whenever you say unique solution, that means only one solution. That solution has to be a zero solution, because that solution is also called trivial solution. So when this happens, so whenever rank of A and the rank of A comma B both are equal to 3, that is both has to be equal to total number of variables. So if you have four variables, it has to be equal to four variables, right? Rank of A and the rank of A comma B, same thing only, right? There is same condition here, but the only thing is you can blindly write that whenever it is unique solution, 0 0 0 is the only solution, and infinitely many solution. There are only two cases. You will not have no solution case. Why? Because we know that 0 0 0 is always a solution. So either this system will have unique solution or infinitely many solution, because we know 0 0 0 is solution, right? So there is no way that no solution is possible, because for every homogeneous system 0 0 0 is solution. Apart from 0 0 0 is a unique solution. That will be infinitely many solution. That will happen if rank of A and the rank of A comma B both equal to 2 or both equal to 1, that is both are equal and less than total number of variables. Both are equal and less than total number of variables. So in that case you will have infinitely many solution. How to find infinitely many solution? To find solution, to find those solutions, follow previous methods. That's it. Follow previous methods. If rank is 2, one free variable, assume z is equal to k. So write the reduced echelon matrix to Ax equal to B form, and then find the infinitely many solution. That's it. So when you are good in non-homogeneous, homogeneous is very easy, just an extension. Okay, so we will do some problems here. Solve the following system of homogeneous equation. Why it is homogeneous? You can see output is 0 0 0, right? So first problem. So we have Ax equal to 0. So first form the augmented matrix. So what is your augmented matrix? A comma B. So see, usually A comma B, but B is 0 here. So 3 2 7 0, 4 minus 3 minus 2 0, 5 9 23 0, right? So we reduce this to row echelon form. R3 is transformed to R2. R2 is transformed to 3 times R2 minus 4 times R1. R3 is transformed to 3 times R3 minus 5 times R1. So this is equivalent to 3270. So multiply 3 here, multiply 4 here, and then subtract. You multiply 3 here, this will be minus 9. Minus 9 minus 8. So minus 17. You multiply 3 here, minus 6. Minus 6 minus 28. Minus 34. This is 0. You multiply 3, 5, subtract. You multiply 3, this will be 27. 27 minus 10, it is 17. You multiply 3 here, this will be 69. 69 minus 35 is 34, and this is 0. So R3 is now transformed to R3 plus R2. So this is equivalent to 3270. 0 minus 17 minus 34 0, 0 0 0 0. So we have reduced this to row echelon form, and we have rank of A to be equal to 2, and also rank of A comma B is also equal to 2. Both are equal to 2. That means both are equal to 2. Homogeneous system. The system is consistent. This is always consistent only. It will be inconsistent whenever there is no solution. So it is always consistent only. The system is consistent and has infinitely many solutions, right? And how many free variables here? So number of free variable is equal to n minus rank of A. So total variable minus rank So which is 1. So assume z is equal to k, and this k can be any real number. Write the reduced echelon matrix, same thing, right? Write the reduced echelon matrix to Ax is equal to b. So your reduced echelon matrix will be 3 2 7 0 minus 17 minus 34 0 0 0, and it is x y z, and this is always 0. So you have 3x plus 2y plus 7z is 0, minus 17y minus 34z is 0, right? And we know z is k. So from 2 minus 17y is 34 z. So y is minus 2 z, and therefore y is minus 2k. And from 1, 3x plus 2 into y plus 7 into k is 0. So 3x is minus 7k plus 4k. So your x is minus k, right? So therefore the solution is x is equal to minus k, y is equal to minus 2k, z is equal to k. So whenever this happens, this will always be a solution. K belongs to any real number. This k belongs to any real number. Let us put k to be equal to 1. If k is 1, minus 1 minus 2 plus 1. You check. So 3 times x. So 3 times x plus 2 times y plus 7 times z. So minus 3 minus 4 minus 7 minus 7 plus 7 0. And 4 into 1 minus 4 plus 6 minus 4 plus 6 2, 2 minus 2 0. Yes. So obviously if you put any value of k, then all those value of k, that set will be a solution, right? So I'll move on to second problem. Second problem. So we will form an augmented matrix. So what is your augmented matrix here? 2 3 minus 1 0, 2 3 minus 1 0, 1 minus 1, 1 minus 1 minus 2 0, 3 1 3 0, right? So reduces to row echelon form. So your R2 is transformed to 2 times R2 minus R1. R3 is transformed to 2 times R3 minus 3 times R2. This is equivalent to 2 3 minus 1 0. So multiply 2 and then subtract. You multiply 2 here, so minus 2 minus 3 is minus 5. You multiply 2 here, minus 4 plus 1 is minus 3. This is 0. It will be 0. You multiply 2, you multiply 3. So 2 minus 9. 2 minus 9 is minus 7. You multiply 2, this will be 6. 6 plus 3, it will be 9, I think. 6 plus 3 is 9, and this is 0. So again, R3 is transformed to 5 times R3 minus 7 times R2. So 2, 3 minus 1, 0, 0 minus 5 minus 3, 0. I think it is correct, right? So just check this out, right? So 2 times R2 minus R1. So minus 2 minus 3 is minus 5. Minus 4 plus 1 is minus 3. And you multiply 2 here. 2 minus 9 is minus 7. Multiply 2 here. 6. 6 plus 3 is 9. Yes. Now this will be 0. This will be 0. 5 times this is 45. 5 times this is 45 minus 7 times this set. This is 45 plus 21. So for 55, 65, some 66 0. Now you can see that rank of A and the rank of A comma B both are equal to 3. And we know that this system is homogeneous, and the system is homogeneous system. And for homogeneous system, whenever both the ranks are equal to 3, and that is equal to total number of variables, it is equal to total number of variables. So therefore uh, the system is consistent and has only trivial solution or unique solution. That means x is equal to 0, y is equal to 0, z is equal to 0 is the only solution. See, as of now, I'm telling you how to solve. The upcoming classes, you will come to know the meaning of all, right? See, check this out. See, there is some correction. We just made it, but your rank will always be equal to 3. Yes, so we'll do the last problem and then we'll wind off this topic. Determine the value of lambda for which the following system of equation has. See, this is a homogeneous system. So either it will be unique or non-trivial. Non-trivial means infinitely many solution. Trivial means 0, 0, 0 is the only solution. Non-trivial means infinitely many solution. Infinitely many solutions. Okay. So first you form the augmented matrix. In an exam point of view, you just write some story, right? This is a homogeneous system. So first we'll form Ax equal to B, and B is 0 here. So it is homogeneous system. So we'll write augmented matrix and then you write this 1, 1, 3, 0, 4, 3, lambda mu. You just show that you know, right? Now reduce this to row echelon form. I always mention you that you always make the unknowns in the last row. So I'm just shifting R2 and R3. So 1130, 2120, 43 lambda 0. So reduce this to row echelon form. R2 is transformed to R2 minus 2R1. R3 is transformed to R3 minus 4 times R1. This is equivalent to 1130. So 0, you multiply 2 and then you subtract. You multiply 2. So 3 minus 6 is minus 4. This is 0. 3 minus 4 is minus 1. Lambda minus 12. This is 0. Now R3 is transformed to R3 plus R2. So this is equivalent to 1130. 0 minus 1 minus 4 0. So sorry, R3 minus R2. This will be lambda minus 8, right? Just subtract. Minus 1 plus 1 will be 0. Lambda minus 12 plus 4. So lambda minus 8. So that means for trivial solution, lambda minus 8 should not be 0, right? That is, if this number is non-zero, if rank of A and the rank of A comma B both should be equal to 3. That means if this is 0, non-zero, then your rank will be 3, right? So that means lambda should not be equal to 8. That means lambda can take any real number except 8. I'm removing 8 from real number. And for non-trivial solution, lambda minus 8 has to be 0. If this is 0, then your rank of A and the rank of A comma B both will be equal to 2. So that means lambda has to be 8. So whenever your lambda is 8, then your system will have non-trivial solution. That means it will have infinitely many solution. And whenever your lambda is not equal to 8, then this will have trivial solution, right? So that's it. So I want to complete this remaining topic. So I made this video. So as of now, we have done with vector space and subspaces. I given you many examples of vector space and we did problems also. In second class, we did subspaces, and in 3 and 4, I have explained you how to solve a homogeneous and non-homogeneous system. Right? How to solve is very very important. So the next class we'll be moving on to linearly independent and linearly dependent set of vectors. Right? That's it. Thank you. All the best.